Hello, welcome to the lesson on sections 3.5 and 3.6. Both these sections deal with something that's called the matrix. Now, when I say the matrix, I don't mean the movie The Matrix with Keanu Reeves, who personally I feel is probably one of the worst actors of all time. But in math, what a matrix is the following. A rectangular arrangement of numbers in rows and columns. So let me give you a good example. This right here is a matrix. Notice how we use brackets to surround it. Also notice how there are two rows and three columns. So this is a great way to organize a certain group of numbers. We also say that matrix A is a 2 by 3 matrix. You always state the rows first, and you state the columns second. So that's how a matrix works. Let's try some examples that deal with the matrix. And by the way, plural for matrix is matrices. Matrices is how you say it in plural form. Okay, so now let's try an example. It's pretty simple. The math is not hard at all. So number one, I'm going to ask you to perform the indicated operation. So here's part A. Say we got 3, 4, 8, 7 plus 5, -8, 7, and 10. So here I'm being asked to add the matrices. So quick question, what kind of matrices are these? The dimensions are 2 by 2. Whenever the dimensions are identical, we're allowed to add them. So here's how we add them. It's very, very simple. You probably might have already guessed how to do it. So in orange, I'll write the solution. You add 3 to 5, which is 8. You add 4 to -8, which is -4. Add 8 to 7, that's 15. Add 7 to 10, that's 17. So you just add numbers that are in identical locations. So I'm adding these two together. I'm adding those two together. I'm adding those two together. And I'm adding those two together. So that's how it works. Okay, let's try another one. One, 2, 3, 4, 0, 8, -5, -4, and 10. So what do you guys think about this one? If you said you can't do it, that's very good. And why is it impossible? Because dimensions are different. They don't match up. So in this case we can't do it. But what if I had this? 1, 2, 3, 4, 0, 8 minus negative 5, 4, 0, 8, negative 10, and 11. This can be done. Let's see here. Go back to orange again. So you 1 minus negative 5, which is 6. 2 minus 4, which is negative 2. 3 minus 0, which is 3. 4 minus 8, which is negative 4. 0 minus negative 10, remember that's 10, so you do minus a negative. 8 minus 11, negative 3. So, not too bad, right? Alright. What if I have this? Let's go back to black. So going back to black, what if I have this? Negative 2, 1, 1, 1, 3, 2, 4, plus 8, 7, 8, 9, 4, 9. Notice how there's a negative 2 right here. So this is what we call a scalar multiplication. We're basically going to scale up each number inside the first matrix. Or I should say scale up, but you're going to scale up by negative 2, meaning you're going to multiply by negative 2. So it's like distributing. So the math is pretty simple, you know, stuff that we've done before. I think you guys can easily handle this. So if we work it out, you should get the following as an answer. And I'm going to skip some steps just to save time, but you might want to pause the video and work it out, and then replay when you have it worked out. I believe you get the following. This right here is negative 2, negative 2, negative 2, negative 6, negative 4, negative 8, yes, yeah. Then add it to this guy, which would be 6, 5, 6, 3, 0, 1. So again, pretty simple. Now I'm going to get into 3.6. So everything I did was really basically 3.5 stuff. Very simple. I'll show you how to do it in the calculator as well, but very, very simple. 3.6. So now I'm going to do a part D. So part D. Let's try multiplying two matrices. This will be fun. Now this might take a little time, so let me stop the video so I can save it, and then I'll create a second one.